So here we are on the reciprocal function. We're looking at a transformation here of a horizontal one of 1 unit to the left and 4 up, and here is our a value. Now remember, the reciprocal function written like this is kind of a concise way of rewriting this. Okay, usually we see the a in front, and to show you how that is so, I'm just going to rewrite the whole thing as such. Okay, so that -2 here is really just outside, and that dot means a multiplication. So let's take a look. We have our basic table of values to begin with. Multiplier of a values by a, which in this case is going to be -2. That gives us 1 here, 1 over, no, not 1 over 2. We get 2 here. Error is the same. We still get an error. And the 1 becomes -2. The 0.5 becomes -1. So you'll notice that basically the negatives have interchanged with the positives, and also, you see some kind of symmetry going on here amongst these numbers. So in the next step and final step, before we graph, we apply our transformation. So in this case, we are subtracting 1 and adding 4. So subtracting 1 from the x's and adding 4 to the y's. What does that do? Well, this becomes -3, -2, -1, 0, and 1. The y's become 5, 6, the error remains the same, 2, and 3. So like before, when graphing reciprocal functions, it's always good to graph the asymptotes first, okay? The h and the k value, if you notice up here, h and the k value, those are your vertical and horizontal asymptotes respectively. Okay, so I'm going to graph them in a red color over here. So I have -1 as my vertical asymptote. So I'm going through here, and I have as my horizontal one 4. So if you remember from method 2, the starting point for a function, again, depending on which one we use, is kind of like a key point. And in this case, the starting point of a reciprocal function is the intersection of the asymptotes, which is right here. It's not a point on the graph, but it's a key point in understanding how the graph behaves. Let's sketch our points now. I'm going to do that with a black marker. I have -3 and 5, so go back 3, up 5, brings me over here. There we go. -2 and 6. Over here, -1 and error, so that's where our vertical asymptote is. And then we are at 0 and 2, which brings me over here. Oops. 0 and 2 over here. And 1 and 3, so 1 and 3 over here. Okay, now that obviously doesn't tell us very much about what the graph looks like, but using your knowledge of the original graph, remember the original reciprocal function, suppose it was just translated, it would be somewhere over here, right? Well, what did the negative do? It flipped it around. So now this bottom part here is going to shift up here. And these are 2 points that I know lie on the function itself. Similarly, this part over here is going to be reflected downwards. And it goes something like this. Really, when graphing reciprocal functions, all I really care about is the behavior of the function in general. These points, for example, these points that I sketched here, over here, 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 yeah, it's good to have them. If I do ask for exact points, I want at least 1 or 2 in the reciprocal case, but I'm more concerned with the fact that you have this. okay, the intersection of the asymptotes, where the asymptotes are. That gives me a lot more information than the behavior of the function close to, say, the origin or whatever, okay? So in the future, identifying where the asymptotes intersect is your most important feature when graphing these type of functions. So restrictions, well, in the x case, we cannot have x equal -1. And the asymptotes, well, those are just our vertical and horizontal transformations. X equals -1, sorry, and y equals 4. And there you have it. So you can get started on the homework. Please open up the file on G Drive, and you have the homework at the bottom. Okay?